With our sine and cosine graphs, we've got a general form where each variable represents something about the graph. Here's the general form we're going to look at. Y is equal to a sine of bx minus c plus d. And for cosine, it's going to be the exact same idea. Y equals a sine of bx minus c plus d. Now, what we need to do with most of our equations is we need to factor out whatever's in front of the x. A lot of times you're going to see your equation written like this. Y equals a sine of bx minus c plus d, or y equals a sine of bx minus c plus d. We need to pull that b out. So we're going to need to factor out a b. That should say cosine right there. We'll need to factor out the b out. And if I factor the b out from there, I've also got to divide the b out from my c value. So my c ends up being a fractional piece of what it was originally. So if you've got a value inside the parentheses that's attached to the x, we need to factor that out so it is outside the parentheses. And the reason for that is we'll be able to see the shifts really clearly. Here we've got a couple of key pieces we want to look at. A here represents the amplitude. The amplitude is how high or how low the graph goes. The B value indicates a period, or how long the graph takes in order to repeat. And we're going to use the formula 2 pi divided by b in order to determine the period. In terms of what our graph looks like, the b value indicates our horizontal stretching or shrinking, whereas the amplitude indicated the vertical stretching or shrinking. So A is vertical, the B indicates the period, which means our horizontal stretching or shrinking. And then we've got C, which is our horizontal shift. How are we going to move left and right? And just as we have with every other function, if it's negative, it moves to the right. If it's positive, it moves to the left. So it's opposite of what you're used to. And then the D indicates the vertical shift. And with that vertical shift, if it's positive, it's up. It's negative, then it goes down. So looking at the different pieces for A, if we're going to have vertical stretching, that means the absolute value of A is going to be greater than 1. If I've got 1, it's my normal function. If I've got 1.5, if I've got 2, if I've got 3, it's going to be stretched up by that factor. If I have a negative value, I take the absolute value. Negative is going to flip it around the x-axis, but doesn't affect amplitude. So we're looking at the absolute value. Shrinking, or the graph getting skinnier, is going to be when my value is between 0 and 1. When we're moving in the horizontal direction, if I'm going to have some horizontal stretching, that's when my B value is going to be between 0 and 1. And if I shrink, that means my B value is going to be greater than 1. The final piece is odd or even functions. When we look around the sine graph, we're dealing with an odd function. And you can do the test that you had back in chapter 1 with plugging a negative x value in and see how does your output respond. Or you can do the reflection around the y-axis versus the origin test. So looking at the different characteristics of sine and cosine, are they continuous or discontinuous? Meaning, do they have breaks in them or not? And both sine and cosine are continuous. No holes, no asymptotes. The period, how long does it take to repeat? It's going to be found by the formula 2 pi over b. In terms of the graphs being odd or even, we just set up here that sine is an odd function and cosine is going to be an even function. And if we pull back out our sheet from before where we had our graph that we drew, we will see that the cosine graph flips around the y-axis, which is why it's even. Remember, it starts at that point 0, 1, and then goes down on the left and up to the right. It looks like this. So I can fold it on the y-axis and I get a mirror image on both sides. The domain for both of these, negative infinity to infinity, makes sense because we've got a continuous function and we can plug anything into it. The range goes from -1 to 1 for both of them. Any symmetries that we've got goes around the origin for sine and the y-axis for cosine, and that's tied directly into the fact that the sine function is odd, the cosine function is even, which is why we're on the y-axis. The zeros, wherever we have a 0 on sine, it's always a factor of pi. So here, n is going to be any integer, and we multiply that by pi, and that's going to be a 0. So 0 pi, 1 pi, 2 pi, 3 pi, 4 pi are all going to result in outputs of 0. If I do it with cosine, it's always going to be the pi over 2 factors. So x equals pi times n, but then we have to add this extra pi over 2 piece to make sure we always get a pi over 2, 3 pi over 2, 5 pi over 2 for my zeros. And then finally, equations for asymptotes. There are none because we've got continuous functions.